Hi, welcome to the Computer Learning Channel. Recently on one of my technology discussion boards, a guest asked an intriguing question. Why don't we have 128-bit computers? The quick and dirty answer is that there is no need for such a computer architecture. As of mid-2026, there are no mainstream, general-purpose 128-bit operating systems. Nor are there any 128-bit processors for common consumer use. While 128-bit computing does exist today, the technology targets specialized data processing tasks like encryption, audio codecs, graphic cards, and specific high-end architectures. In today's mainstream computers, the 64-bit register can hold up to 16 exabytes of RAM, which is approximately equivalent to 16 million terabytes. From an arithmetic perspective, that value is larger than what is needed numerically in our daily lives. That said, it does not mean 128-bit systems do not exist. There are specialized systems, like the IBM AS400 System I, that has used 128-bit pointers for decades, and some high-end Google storage systems that use 128-bit register values as file pointers. Also, many modern mid-range to high-end NVIDIA graphics cards, such as the RTX 4060 Ti and the RTX 5060, use a 128-bit memory bus. Let's go back in time to 2003, when AMD released its first 64-bit processor. And in 2005, when Microsoft released its first 64-bit operating system. The main driving force back then for the migration from the 32-bit CPU design to the 64-bit architecture was the need to increase the computer's ability for accessing RAM beyond the 4 GB barrier imposed by the 32-bit system. From a practical side, we did not need the full 64-bit register to access the max RAM capacity of the current generation of processors. All that was required was the extra bytes beyond the 32-bit limit, and that has been more than sufficient to grant us ample RAM capacity for today's computers. That development and change in design has elevated the pressure on us from pushing or implementing the 128-bit processor anytime soon. Today, most modern 64-bit processor manufacturers implement 40 to 52 bits for physical addressing on their systems bus, supporting between 1 terabyte and 4 petabytes of RAM. The actual usable RAM on any computer system is usually determined by the operating system version and motherboard hardware, rather than just the CPU architecture. Populating a computer with its maximum capacity of 64 exabytes of RAM is a theoretical scenario. Theoretical because that amount of memory exceeds the total annual RAM production capacity of the world today. Not only that, housing such large amount of hardware will require a massive dedicated data center facility with millions of free square footage. As for the physical servers, and assuming we are using high-density servers, we would need hundreds of thousands of servers just to rack that amount of RAM modules inside them. Beyond the RAM limitations we mentioned, and even though modern computers technically utilize 64-bit processors, they are still able to process integers, floating point numbers, and vectorized numerical extensions in a 128-bit format natively for uses other than RAM operations. Other obstacles that can hinder the development of a larger bus in computer processors are the constraints imposed by the materials involved in manufacturing the CPUs. But even if we were successful in overcoming those hurdles, manufacturing a 128-bit computer can prove difficult because you have doubled the bus width that goes from the CPU to the peripherals. And that creates new challenges and logistics of how those extra bus lanes are going to reach their destination connections design-wise. Not only is the bus layout and design going to be difficult, but also the physical size of the CPU and the dimensions of the motherboards are going to be increased dramatically, making the manufacturing process more resource-intensive and cost-prohibitive. When manufacturing 128-bit CPU chips, they are printed on silicon wafers. As a matter of fact, multiple chips are printed on a single wafer. The 128-bit CPU uses more transistors than the 64-bit, which means they are larger in size. Thus, less of them can be printed on a single wafer, making them more prone to manufacturing defects. Not only is the manufacturing process an issue, their larger size means they generate more heat than their 64-bit counterparts, which implies that we will have to run those CPUs at a lower clock speed to keep them within safe operational limits. So now that we understand those limitations, the question would be, is it worth going down that path? For some specialized cases, maybe yes, but for mainstream, it is a balancing act. Some applications like games might benefit more from the higher clock speed at 64 bits rather than having the larger data bus of 128 bits. From a manufacturing perspective, companies and engineers seem to favor more cores per CPU rather than going to 128 bits path for now. Also, companies are investing in other technologies like quantum computing and light-based computing as a path forward to augment the technologies we have, rather than just looking only at the 128-bit architecture as a mainstream computing design. What the future brings technology-wise, we may never truly anticipate. So we can't really say that we will never produce a 128-bit computer to the mainstream public. Jumping from 8-bit to 16-bit, then from 16-bit to 32-bit, and later from 32-bit to 64-bit CPUs were all dramatic changes that came with big improvements to the computer industry. But jumping from 64-bit to a 128-bit CPU might not deliver the desired or anticipated improvements compared to the previous generation of CPU design milestones, even though they were released over 20 years back. The jump to 128-bit is an engineering decision and a balancing act between a larger data bus versus more cores on a single processor, or a decision for a 128 wider data bus versus pushing the clock speed on current motherboards and CPUs to a new plateau. In conclusion, 128-bit processing might not be implemented on the motherboard of modern mainstream general-purpose computers, but the 128-bit technology is already integrated into some of our modern computing subsystems and is used in some specialized computer tasks. Thank you for watching this tutorial. I hope it helped. Don't forget to like and subscribe, and I will see you on the next video.